Hi everyone, so today I'm giving an introduction into Math CBA1 that is titled A Mathematical Investigation. And our class will be starting this on January 3rd, that's the Monday when we come back, and we'll be doing the CBA for a 3-week period up until January 21st, that's the Friday. So the learning intentions for this lesson are that students should be able to describe what a CBA is, list the steps involved in completing a mathematical investigation, evaluate sample student CBAs using the marking scheme, summarize what is required of them throughout the 3-week CBA period. What is a CBA? A CBA stands for Curriculum-Based Assessment. You may have seen this in some of your other classes so far. Achievement. On the CBA, your grade is recorded on the junior cycle profile of achievement that you'll get at the end of third year. This is an in-class project. It's done in class only, so you can't bring this home, you can't work on this at home at all. You can work on supporting materials at home, but the project is to be completed in class. So for 3 weeks, we will be only working on a CBA. This project allows students to engage with maths. So before in maths class, you would have often been solving calculations and maybe doing some problems, but it's hard to relate that to real life stuff a lot of times. So this is a really good opportunity for you to actually engage with the maths and apply it to something that you're interested in, that relates to you. Okay, so here we have some maths memes that I found online, and these memes really resemble what I hear from students all the time. So I was good at maths until the alphabet decided to get involved, and letters and any other subject, letters and maths are scary and confusing and make everything so much harder, but there is a really good reason as to why we use these. So we use algebra for a good reason, and it has huge application in real world problems. Maybe not so much the stuff you see every day in your lives right now, but in the future you're going to be using a lot. You're going to find yourself using a lot of algebra, and you're going to use a lot of algebra in your project right here. So say if you're a taxi driver and you want to figure out how much money you can make, you want to figure out your pricing. So maybe you're going to charge €4 as soon as someone gets in the door, and then you're going to charge a $5 for every kilometer you travel after that. So the price is going to be different every time because the distance is going to be different every time. And in your equation, when you're looking at this, you might want to graph it, maybe how much you charge per distance, and make sure your business is profitable. So there's good reasons why we use placeholders. These placeholder letters in maths, they're not just there to make everything harder on you. And you're going to get to engage with this and see this for yourself, hopefully. So what is the Math CBA all about? A mathematical investigation. It's in this investigation, you're going to be choosing a real world problem which interests you. Okay, and you're going to attempt to solve this problem using maths and something we call the problem solving cycle. At the end of this, you're going to produce a report using Microsoft Word and have a nice PDF explaining the process you go through, why you go through it, why this is a problem, and the steps you take to solve it. And you can look at your results, and then maybe you're going to come up with a conclusion. Maybe say, oh, this idea is profitable, or this idea is not profitable, or this will work, or this won't work. So it doesn't matter if it does or does not work out. That's not what's important. It's important it's an investigation. Okay, you're just looking at something and you're going to use maths to decide whether something is good or bad, or profitable or not profitable, or whatever the problem is you're investigating. You're going to look at that and try come up with some sort of a conclusion. So what is this problem solving cycle? It's something I'm going to be using a lot. This problem solving is becoming a much bigger thing in maths, especially on the Leaving Cert. You're going to see a lot of problem solving, so it's good to engage with it now. So first off, we define a problem, and that's the first part of this investigation. We come up with a problem and we define it. So to define it means we have to list out all of what's going on with the problem. So it's not enough just to say, oh, I want to look at the money I can make as a taxi driver. You're going to have to define it a little more, make more assumptions. Maybe say, oh, I'm only going to be a taxi driver in town. I'm not going to go further than 10 kilometers. Or maybe you have to make an assumption that your taxi only has 4 seats. You can only take at most four passengers at a time. And then you're going to have to simplify your problem. You're going to break it down into manageable steps. So you're not going to solve your problem all in one go. This is the same with all problem solving you do. You have to break it down into small, manageable steps. No one can solve these big problems all in one go. That's not how problems get solved in real life. They're broken down into steps and they're done bit by bit. And then you're going to want to translate your problem into mathematics. That's a big part. And there are some worksheets there to help you with that. But so often in maths, we're so used to doing our calculations, which are nice and easy. We plug them into our calculator and we get our answer. But when we have words, it often confuses things. So it's important we take the time to try and translate those words into maths, into something we can plug into the calculator and can find a solution for. So that's the next step, is to translate. And then we have engage in this problem solving cycle. You have to engage with and solve the problem. So once you've everything translated into maths, something you can work with the maths, you're going to want to engage with that maths and look at different techniques and methods to solve the problem. Maybe you have to do a simultaneous equation. Maybe you have to use the quadratic formula. So this is you engaging with the maths and trying to come to some sort of solution to find out what some sort of variable is. That's you're engaging with the maths. And then you're going to want to interpret. That's the last step. You interpret the results. So you're going to look at your results, and maybe you'll find that as a taxi driver, even working 40 hours a week, the most money you can make is €100 at your current pricing. That's no good. So that's not going to be viable. That's not a good way to live when you're making that much money and working that hard. So you might have to readjust your pricing. So you can say that in your interpretation. You can make comments. You can say, oh, this works really well this way, or this doesn't work so well. That's what the interpretation is about. So that's our problem solving cycle. We define, simplify, translate, engage, and interpret. So what maths is involved in this project then? So complex maths is not necessary. You don't have to go looking at crazy complicated formulas. You can if you want, but I would not recommend it. I'd say keep everything simple. We just must have maths present in every step. Maths must be used the whole way through. So when you define your problem, you're going to have all the wordy bits there. You might make some assumptions. They'll be in English too, but then you're going to want to translate all of those to maths as soon as you can. You're going to want to use as much maths as possible. So everything you write in English, you're going to want to try and translate to maths. So you're going to have maths in every single step. Okay, you don't have to do anything wildly complicated. Just the stuff we know from class. That's enough. That's all you need to do. You don't have to go do anything crazy. Yes, so translate into maths as much as possible. So the marking scheme then for this. There are 4 areas which determine your grade. So you grade on defining the problem statement, finding a strategy or translating the problem into maths, engaging with the maths to solve the problem, and interpreting and reporting. So we're going to look at these in more detail now, and we'll see them here on the marking scheme. So here we have this big, long looking, confusing looking marking scheme thing here, but it's not that bad really. So we have 4 different categories things can be graded as. The lowest category here is yet to meet expectations. And then we have in line with expectations. Next we have above expectations. And then finally we have exceptional. We're only going to really focus on the exceptional stuff here, okay? Because that's what we're going to be aiming for. We want to all be aiming for exceptional, and then maybe if we don't hit the mark, we'll hit above expectations. But exceptional list out all the things we should be doing, okay? And so as we said in the last slide there, we're defining the problem statement, finding a strategy, or translating the problem to mathematics there in orange. And then in yellow here, we have engaging with the mathematics to solve the problem. And then down here in gray, we have interpreting and reporting. So exceptional for defining the problem statement. Poses a concise problem statement and clarifies and simplifies the problem by making justified assumptions where appropriate. So what does that mean? What does it mean to pose a concise problem statement? Well, concise basically means specific, and specific is a big thing. So it really needs to be specific. Can't be overly broad. Someone should be able to read your problem statement and know exactly what you're talking about and what you're going to investigate and what the results should look like. So they should be able to realize all that from your problem statement. They shouldn't have to read any further than your problem statement to figure out what's going on in your problem. You should also list out your assumptions. So like I said before with the taxi driver, are we driving a 5-seater taxi, a 7-seater taxi? Like we have to list out all the assumptions we're making. Obviously, we're not going to go and start a taxi company for this project. We're just imagining it. So we have to list out the assumptions. We have to list out all of the assumptions. Okay, so then for finding a strategy or translating the problem to mathematics, we have develops an efficient, justified strategy and evaluates progress towards a solution where appropriate. Conjectures relationships between variables where appropriate. So we'll develop an efficient, justified strategy. So it's important that we justify our strategy. It's important that we say why we've chosen to take these steps. It's important you let the reader know why you're doing what you're doing. Evaluates progress towards a solution where appropriate. So as you go, you kind of want to be saying where you're going to want to be letting people know where is this going to lead, where is this leading to. And then conjectures relations between variables where appropriate. This is an important one. I have a worksheet there to help guide you on finding relationships between variables. It's important to note this because we really want to, because that's a lot of what we're going to be doing in this project for a lot of people, I think. So you may want to investigate. We're going to go back to the taxi man again. So investigate how the rate changes with relation to how many people are in the taxi. And you're going to want to look at those two variables and compare them to each other and say, oh, we're making twice as much money when we have a full taxi as compared to when we have one person, or it's the other way around. You're going to want to say how things change depending on your variables. Okay, and then engaging with the mathematics to solve the problem. Mathematical procedures are followed with a high level of precision, and a justified answer is achieved. Solutions/observations are generalized and extended to other situations where appropriate. So mathematical procedures are followed with a high level of precision. So you're not being graded on complex maths, as you can see. It's just following the procedure with a high level of precision. So being accurate, not making many mistakes, and doing things correctly, basically. And a justified answer is achieved. So you want to use your maths to achieve a justified answer. So an answer that is within reason. And then solutions/observations are generalized and extended to other situations where appropriate. So this is a good one. So you might come up with a formula for the income of a taxi driver, and then you might be able to generalize that formula for, say, a fleet of taxis, a fleet of 5 taxis, and you might look at that situation. So you're going to want to take whatever solution you have and try to generalize it for different situations. That'll really add a lot to your report. So then interpreting and reporting, we have deductive arguments used and precise mathematical language, and symbolic notation used to consolidate mathematical thinking and justify decisions and solutions. Strengths and/or weaknesses in the mathematical representation/solution strategy are identified. Okay, so this is a big one. So deductive arguments and a precise mathematical language and symbolic notation. So deductive arguments, you want to be making good arguments using your mathematical language. So translating everything to maths will really help you with this. So if you're translating everything to maths as you go, and your strategy makes sense in English, once you translate that to maths, if you're doing that correctly, you're going to get good marks here. So, and using correct notation. So using all the correct notation in the maths language you're going to find in your textbook. And then justifying decisions and solutions all through maths. And then a big part then is to talk about the strengths and weaknesses in the mathematical representation. Okay, so talk about what's good about the way you did things, and importantly as well, talk about maybe what's not so good. Where are there maybe sources of errors? Where can things maybe go wrong and in the assumptions you made, or was there an assumption you forgot to make? Or it's important to judge at the end what went right, what went wrong, because maybe at the end you're not going to have time to go back and do it all again. And if that happens, that's okay. That's no problem. Just talk about it. Say why you went wrong. Say what might be better to do next time. Okay, and that's really important there as well. So if we look at maybe the above expectations for defining the problem statement, maybe why you're not going to get the full mark for that one. So this one here really depends on how much guidance you get from your teacher, from me. So with very limited guidance, you can still achieve above expectation. With a good bit more guidance, you're probably only going to get in line with expectation. And if I have to give you a problem statement to work with, you're going to get yet to meet expectation. So this is all about independent work, independent research. I'm going to provide supporting materials that will help you along the way and give you everything you need, but I can't do the project for you. This is something for you to engage with yourself. It's really important that you do that. Again, yet to meet expectation for finding a strategy, translating the problem to maths, use a given strategy. So if I have to tell you what to do, then you're not really engaging well with the project. You need to be engaging with this yourself. So yeah, so with limited support from me, you will the grade changes there. And then engaging with the maths. So record some observations, so not recording all your observations, not following proper procedure. So that one there, you just have to follow everything, proper procedure, use good technique, and then generalize then as well to get the top marks. Okay, CBA evaluation task. So this is something we did in class, but if you're watching this online for the first time, it'd be really good for you to try this yourself. So read through the sample student CBA. The one we did was the cheetah enclosure. So read through that and use the marking scheme there that's on the website as well to tick off which category you think you would give the student for each section. So exceptional, above expectation, in line with expectation, or yet to meet expectation. And then decide on an overall grade. So I want you to try that now actually, before you continue on with these slides. It'll be good exercise for you to do if you haven't done it already. If you've already done it and you're just looking at this as a recap, that's perfectly fine. We can move on. So defining the problem statement. So here you need to be specific and clear. It's really important that you're specific and very clear. Someone who doesn't know anything about your problem should be able to read your problem statement and know exactly what's going on. They shouldn't have to read any further than the problem statement to know what's happening or what way your project is going to go or what the results could look like. So it needs to be realistic and reasonable. That's really important. So I think it might be silly to assume you're a single taxi driver with a budget of €1 million to invest. That's a bit unrealistic, okay, and unreasonable. So try to keep it reasonable. I think it'll help yourself. It'll help with yourself just thinking about things reasonably and logically. It'll be more realistic and easier to look at the maths then. So it's really important you list the assumptions you're making as well, as we said before. And then your reasons for choosing the project are also important. So why is this something that interests you? Why did you choose to do this project? That's something that we want to hear. So yeah, why do you want to do this question? And the reasons for choosing, maybe you think it's maybe you're looking at animal conservations and you really like animals and you want to help protect animals, so you're looking at an investigation for that. Or maybe you're looking at climate change and that's a big issue right now and it's something that maybe you're really interested in. So those could be some good reasons for picking a problem. Okay, so here's another task we did in class, but if you're watching this online for the first time, it'd be a good idea to do it now as well. So we got each person to come up with a problem statement. So try come up with your own problem statement now. Just take 5 minutes. And then I want you to be thinking about the whole way. Is what you're doing specific and clear? Is it realistic and reasonable? And do you have good rationale, good reasons for picking it? So I want you to do out a problem statement and then read back through it and see, is this specific and clear? Do I know what's happening? Do I know what results to expect? And then is it reasonable? Does it make sense? And what are your reasons for picking it? Okay, so finding a strategy or translating the problem into maths. So we need to come up with a logical strategy, a strategy that makes sense. And then list the steps you will take and why. And then after we've done all these Englishy parts, we want to translate this strategy into mathematics if we can. So then we should be coming up with some variables of our own. And then we want to think about what variables we get and how are they going to relate to one another. And maybe how are we going to relate to one another, we might see that a bit more in when we actually go to solve the problem. We might want to think about what we can when we're coming up with the strategy of how they relate to one another. And then we might want to find out how maybe one variable relates to another. Maybe we don't know right now. And then we do the maths and we find out. Maybe that's the overall goal of our project, is to find out how one thing relates to another. Maybe how lung capacity relates to the average swimmer's speed. Maybe that's something you're interested in, and that's definitely something you could have as your problem. Okay, then engaging with the maths to solve the problem. So we're really looking at precise use of mathematics, no crazy complicated maths. There's no need for that, but precise use of mathematics. So doing things correctly, doing things the right way, and showing it properly, showing all your steps. You know, you're not going to get marks for anything you don't put down in this project. So everything you do, you need to put in here. And generalize your solutions. That's a really important one. That's where you get the big marks, for generalizing your solutions and looking at it in different situations. And then you want to, so you want to look at if your solution can be applied to different circumstances. and then maybe try to produce a general expression, equation, or formula. That'll really help with generalizing your solutions. Interpreting and reporting, so precise use of mathematical language and symbols for describing logic and solutions. Identify strengths and weaknesses in your own solution. If your solution doesn't work, describe why and what you could change to get a reasonable solution. So your solution doesn't have to work out perfectly in the end, and you can still get good marks in this investigation, because investigations aren't about solving problems, they're about looking at something, about looking at a problem. It's not necessarily about discovering anything great or inventing anything new. We're just taking a look at something and deciding if it's viable, not viable, or maybe we're looking at our solution and deciding if it's viable, not viable, if it works or doesn't. So here we have our timeline. So this is the suggested timeline for the CBA. So I'm going to show you how to read this now. So on the top here, we have our days of the week: Monday, Tuesday, Wednesday, Thursday, Friday. I only have Monday to Friday here because we're only working on this in class. Okay, and this top section here is week 1. This is our first week. So in white, this block here, this is where we're going to be working on defining our problem statement. You can see that white block stretches from Monday right to Friday there. And that doesn't mean you have until Friday to do it. You should probably be finishing up on that probably around Wednesday, but it is okay if you're still working on it on Friday. Okay, and then around Wednesday we want to start, you should really be starting to look at your strategy and the maths you're going to use. Okay, it's important to start looking at your strategy and your maths. And if you see then down here at week 2, strategy and maths continues on until the next Friday. It's okay to keep working on until next Friday, but defining the problem statement doesn't. Okay, so you really shouldn't be defining your problem statement anymore come week 2. That should be done. Okay, because if you're still defining your problem statement, then you're really not going to have enough time to do the rest of the things you need to do. Back then, again, here in week 1, you'll see we have WS1, WS2, WS3, and WS4. These are worksheets. Okay, so worksheet 1, 2, 3, and 4. So worksheet 1 is due on the Monday, worksheet 2 is due on the Tuesday, 3 on the Wednesday, 4 on the Friday, or the Thursday. And these are really important to do. These little worksheets will really help you. So the first one is on translating to maths, and then we have relationships between variables, and these things are really going to help you when you're thinking about your strategy, and even when you're defining your problem statement. They may even help you, give you ideas in regards to that. So it's really important you're doing these, okay? And so you have to upload these to Google Classroom, and I'll hand out the worksheets at the end of class each day, and if you're not in class, they'll be up on my website as well. And so will the solutions. The solutions will be released. Well, the solutions are up on the website, but the code for the solutions will be released after the worksheets are due. So you can look back on the solutions if you need to, if it didn't go right for you. So that'll be there to support you throughout this process. And then in week 2, we're going to want to start around Tuesday. You really should start looking at solving your problem, because you want to give some time to solving your problems. That's important. That's not the main thing I'm going to say, but it's what you might think the main thing is. But really, it's in equal parts. So you get equal marks for defining your problem statement, for your strategy, for solving the problem, and interpreting results. So it's not all about solving the problem, but it is an important part. You want to start looking at that around Tuesday. And then come the 3rd week, come Tuesday of the 3rd week, after Tuesday, come Wednesday, you really don't want to be looking at solving the problem anymore, because you want to be doing up your report, interpreting results, talking about your results. And that's a really important part of this process. Okay, it's interpreting results and giving comments. Okay, and then the Friday then of the final week, it's due. Everything should be done by then. You should have converted your Word document to a PDF and submitted it to Google Classroom. Okay, so here we have a recap of the introduction. So what is a CBA? A CBA is a curriculum-based assessment. It's an in-class project that we do. We do it in class only. It takes 3 weeks. And our achievement is going to be recorded on our junior cycle certificate of achievement. So what are the steps involved in completing a mathematical investigation, the Math CBA1? So we have to define our problem statement. We have to come up with a strategy. We have to translate all of this into maths if we can. And then we have to go about solving our problem. And then we have to go about interpreting our results. And then we want it all nicely reported in a Word document that we can convert to a PDF and submit on the Friday of the 3rd week. So what is required of you throughout the 3-week CBA process? So what do you need to be doing? So in class, we're going to be working on the CBA only for 3 weeks. So outside of class, you have your worksheets to be working on, which will support you in this process. And you have all of your other things you can be looking at as well, like your formatting, how to and your formatting and other supporting materials, which you'll all find on the website. So you should be looking at all of this so that when you come into class, you can be working nonstop on the CBA. You should have no stoppages. You can be just keep going with your research, because 3 weeks is not a hugely long time. You know, you want to try get through a good bit in the CBA, because it's a really good opportunity if you engage the maths. And I think it can be a really fun project if you can come up with a nice problem statement. That's probably the most difficult thing, is coming up with a nice problem. Once you have your problem, I think you're going to really enjoy going through this process. So questions, any questions? Obviously, I can't take questions from you right now because this is an online video, but if you do have any questions and you're watching this online, you missed the class, feel free to email me, dnally@cc@loan.ie. Get in touch with me there if you can't get in touch with me in class, or just in class if you can, and I'll be able to help you out as much as I can. And all of the supporting information documents are up on the website along with the information sheet. You should go through all of that first before you come to me with questions, because whatever you're looking for may already be up there and your questions will be answered there. Best of luck, guys.